Let's build our porch and margin generator. So I'm going to go ahead and just add in all the parameters here, speed up the video, and then I'll go back and describe them. So the idea here is that we've got all these parameters in, and in particular, we're going to be taking in the horizontal count and the vertical count. These are the two pixel counts for the horizontal pixels and the vertical lines that include all of the active and inactive regions. And we're going to take those raw counts and apply these counts to them in order to get a determination as to when we are in the active area of the display, and also intending to output a count of the actual active horizontal and vertical position. So let's go ahead and add those outputs. So we're going to output the single bit that just indicates whether we are in the active area or not, irrespective of what row and column we may be on. For the test harness that I'm going to write, again, if you watch the intro video, I talked about a test pattern generator. I'm just going to write a way to shoot out various test patterns to the display to just prove that everything is sort of working. But when this component becomes integrated into the Hack computer, we're going to need to know what row and column the display is asking for, so that we can fetch that from memory and return it. And so that's what these two are going to be used for later. So let's deal with pixels on a given row. First thing we need to know is, when have we got past the horizontal sync pulse, and when have we got past the back porch? So we're going to need to add those together. And one thing that I forgot to do is I typically like to put tunnels on these. So I'm going to go off and speed the video up and just put tunnels on these things, and then I'll get back to the adder. We need to know when we're done with horizontal sync pulse and when we're done with the horizontal back porch. So let's go ahead and add those together. So now at this point, technically the active area has begun. So we need to know when we get to the end of the active area. So let's put in another adder. And let's add to that the active pixel count. Now at this point, if we're between the number output from this adder and this adder, we know we're in the active area for the current line that we're on. However, we want these H margins to be taken into account here. So what we're going to need to do is we're going to need to add margin to this value and subtract margin from this value in order to do our comparison. So let me add in those arithmetic operators to do that. So now we need some comparison operators. If we're greater than or equal to, and remember this is zero based, so if we're greater than or equal to this number, this is the number with the margin, or we're less than this number, and oh, oops, I just realized this is plus, this should be minus, because we should be subtracting the amount of margin on the right-hand side of the line. So let me fix that. Right, so if we're greater than or equal to the lower bound, and we're less than the upper bound. So let's put those comparators in here. And again, these should not be 2's complement. They should be unsigned. No negatives. And we need another comparator. Here. I'm not quite sure why this is showing red. Probably because I probably don't have all these hooked up. Okay, yep, that was the problem. And I think I need to move all these over. If we are greater than or equal to, so that means we need an or. And less than the upper bound, so that means we need an AND gate. This means that we're in the active area for the current line, but that doesn't speak to whether the current line that we're on is in the active area or not. So we essentially need to duplicate this logic for the vertical. But to avoid making mistakes, I'm not going to copy paste because all of these labels are different and our bit lengths are different. So I'm just going to go ahead and draw it out. Right. So now if we're in the active area here and we're in the active area here, then we're in the active area. So sounds like an AND gate to me. And just like that, that takes care of the porch and margin generator to at least spit out whether we're in the active area or not. So let's create the logic that spits out the counter variables for when we're in the active area, both horizontally and vertically. And I think the simplest way to do this is we know that we're in the active area when either one of these AND gates outputs a true. And so what we could simply do is put a multiplexer in looking for true on this signal. And when we're true, we just put out the H count minus the sync signal, the back porch, and the margin. And we already have that. And if this signal is false, we just output a 0. Now, that has the effect of whether you're below the lower bound or above the upper bound, you're going to get a 0 on the count, which may be a little bit odd, but you're going to have the active signal to know whether or not these values, considered active or not. So I don't think that's a big deal. You could do the math to either put out the maximum value or the minimum value, but I think that's just extra work that's not needed. So let's go ahead and create a couple of tunnels to identify when we're in either horizontal active or vertical active. And I already have an H active, unfortunately, so I'll just call this H active B for bit. When this bit is true, when the left margin begins at the point of 0. So we just need to do some subtraction in order to be able to get that value. Probably what we'll do is we'll create a tunnel for the lower bound right here. I think that's easiest because we already have the addition to get what the lower bound is. Now we can just do the subtraction. From our counter, horizontal counter. Subtract our lower bound from it. And then what we need is a selector, or I'm sorry, a multiplexer. So when horizontal active is true, then we want the result of this subtraction to be output to our counter. If, on the other hand, this is false, we just want a 0 put through. And I believe that should work. So we just need to do the same thing to the vertical. And I think that should complete our porch and margin generator. So the last thing we need to do is that as inputs to this module, we're putting in the horizontal counter and the vertical counter. And on the last video where I produced the sync pulse generator, I did not output those counters. So let's do that. Now I'm going to do a little bit of cleanup here. So one of the final changes I want to make is not really a change to the functionality, but if you recall if you watched the last video where I produced this, I was having a bug with timing and synchronization for when you get to the end of the horizontal line, rolling over and incrementing the vertical line counter. And the solution that I have in here works, but it's frankly ugly and it always bothered me the way I did it. So it occurred to me, I guess, more straightforward solution. So I'm going to go ahead and implement it and talk about it because it just was obvious after after I did this. When the horizontal counter gets equal to the horizontal total, we're actually one past the pixel that is valid for the horizontal line. And at that point in time, really instantaneously, we should be setting the counter back to 0. And so the original way that I had this drawn was like this, because this clear is an asynchronous clear. So this is technically correct. Now the question becomes, at what point should this vertical counter get incremented? Well, the logical way, and the way that I had it, was that you would increment the counter at such point that the carry is true. However, the carry is true only instantaneously because now of the way this is wired up, right? Which is not enough time to increment this counter, which happens synchronously with the clock. So what you really need to know is, when are you at the last valid pixel? And so in order to do that, that's really why this subtraction was here. Although it's awkward for it to be here sitting off of H tote, it really should be an input to this counter sort of by itself. And finally, we're never going to load 0 then back into this horizontal counter. So we're going to get rid of this. And then we're going to wire the load to ground because we're never going to load it again. So what we're going to do is we're going to remove this, and then we're going to just subtract 1 from H tote. Now, once the counter, the horizontal counter, gets to the point at which this is equal, well, we now know we're at the last valid pixel, and that is the point at which when this counter should go high to indicate that a new vertical line is going to be reached on the next clock tick. That's sort of the key. When we're at the last horizontal pixel, that last valid one, we have to raise this enable high because it will be on the next tick when this line counter will increment, and that's what we want. So what we need is a comparison comparing this value, which is the end horizontal pixel, to H count. And so the point at which that that comparison is equal, that's when we want to increment the counter for the vertical line count. In the next video, we'll put together a test harness and talk about the electronics required to hook up the physical VGA interface to our FPGA and hopefully get the beginning picture from all the work. Thanks for watching.